Hello, welcome to lesson 2 in the second spiral, and we're talking about scatter plots today. So I can demonstrate understanding on how to create a scatter plot and understand its purpose. So there's a couple definitions we have to work with first. I'm just going to go through them quickly here. So axes, an axis is part of our Cartesian plane. Cartesian plane. So to give you a visual, we know we have our x and our y. All right, and both of those are what we would call axes. All right, now our dependent variable. Dependent variable is the outcome of an experiment. Okay, it is what we are measuring. All right, and this typically, okay, is always your y-axis. Your dependent variable, we always put on the y-axis. So what we're measuring. Our independent variable is our input or control value. All right, so for example, in a science experiment, you might be measuring time. All right, or maybe you're controlling temperature. Okay, it is what you are controlling. All right, so this is always put on the x-axis then. And an outlier is a piece of data that does not fit. I'll put that in quotations. Okay, so it's a piece of data that it doesn't fit with the overall or the other data collected. And I'll point this out when we do an example so you can get a feel for what it really means. All right. So what is a scatter plot? So scatter plot is a collection of points, or we can call them coordinates, that are placed on a Cartesian plane. All right, and when do you use scatter plots? So this would be a discussion in class. You're missing that because we're doing it through video. So scatter plots are used for graphing experiments. Okay, so it could be science. That's where your mind jumps right away. So if you're doing an experiment in science, but you can also do a scatter plot in history or geography. All right, if you're collecting information. All right, so it doesn't have to be just science, but that's the one that's probably going to be most common for yourselves. All right, so if you haven't caught up with coffee, make sure you pause the video at this point so you can copy that down. And if not, let's continue on. So what you want to do now is you definitely want to pause the video. I have my imaginary students here with all their information. So pause it and collect the data, and then we'll move on. All right, so now that you've copied down the data, class data, we're going to move on. I'm going to go to the questions, and then we'll come back to the graphs here. So I need to know what I'm graphing. So in the questions that you know, it says, does the scatter plot show any type of relationship or trend between foot length and arm span? So I got a plot on my axes. So it listed foot length first. So I'm going to put foot length across here. I'm going to put arm span up here, and we're measuring everything in centimeters. I got to figure out a scale. When I look at foot length, it looks like it goes up to 65. So what I'm going to do is every second notch is worth 10. 40, 50, and 60. Going up the y-axis, my arm span, it looks like has to go up to 500. So I'm going to go let's say every other is let's keep it simple. Let's go by hundreds. Every other. Oops. Except it should go up. So this would be 100, 200, 300, 400, and 500. I could have maybe spread that out a little bit better. Now I'm going to go ahead and plot the points. So I'm going to pause the video and plot those points. It's going to appear to you when I start up again. All right, so I plotted my points. Hopefully paused it and you got yours done as well. So let's take a look at this quickly. So what do we notice? A couple of things I'm noticing. Here's our outlier. All right, I said I would show you what it looks like in the video or in the example. There's our outlier. All our other data is grouped right here, but that outlier is not with the data. So why is that? Well, who are we talking about here? And our outlier is Hulk. And we know this is going way back because Hulk's a pretty old guy now. But anyway, Hulk is definitely an outlier. I'm not sure who was brave enough to do the measurements on Hulk when he went into his beast mode there. But anyway, he is the outlier here. So he is the example of why we have a piece of data that doesn't fit. The rest of it, as I said, it's grouped together here. It's just a big blob. So when we answer our question, okay, is there a relationship between foot length and arm span? I would say no. The data forms a blob on the graph. All right? There's really no particular trend there that we can see because it just forms that big blob. Now the second part, they want foot length and height. So I need to go back and I need to finish that second graph. So going back, I'm going to give you some time. I'm going to plot the points, but I'll help you out here. So we're going to put foot length. We're going to put height. All right. And I see that, again, height, what are we going from? We need to go up to, say, 400. So I'm going to space it out. Every 4 is going to be 100. 1, 2, 3. So there's 100, 200, 1, 2, 300, 400. All right. And for foot length, what was it before? I can't remember now. Foot length, was it foot length or arm length that we're supposed to be doing? We're supposed to be doing foot length and height. So it looks like it goes up to 65. So again, I'll spread this out. Let's go up by every second square is 10, 30, 40, 50, and 60. Now I'm going to pause that video and plot those points. All right, so I've got my points plotted, and you can see again, good old Hulk, he's our outlier again. All right, he's not falling within the data at all, but the rest of them seem to be a little bit more spread out, or a loose pattern is formed here. So if you can see above when we talked about pattern, this it wasn't really stretched out. It's kind of in a square blob, where this seems stretched out a little bit more. So we could almost say that your conclusion would be, as your foot length gets greater, your height gets greater. So there's kind of, and I'm going to just freehand a sketch in of a line. There is kind of a line that it's following up there. Okay? So when we answer our questions here, is there a relationship between foot length and height? I think we can say yes. The data shows the taller you are, the bigger your feet. Which makes sense. If you're a tall person, you should have bigger feet. Bigger your feet. All right. So are the relationships weak, moderate, or strong? So for part A, so the foot length versus arm span, I would say no relationship. So I guess in this case it would be very weak if I have to answer that question. And for B part, the second graph, the way I look at it is if all your points fall in a very narrow corridor, think of it as a hallway, okay, they all fit in fairly snug. They're following that red line I kind of sketched in. So I would say it's definitely moderate to strong, okay, and it is a judgment call. So if you gave me moderate, I would say you're correct. If you gave me strong, I'd also mark that correct as well. All right. If a person has a height of 106 or 175 centimeters, what's their foot length? So we gotta go back to that graph. We need to find 175 centimeters. So using black, I guess, 175 is right here. So if I go across, it's in this region right here, I would expect a person to have a foot length of about 35 centimeters. So just reading from the graph of information. So I would expect a 175 centimeter tall person to have a foot length of 35 centimeters. Now, the next question. If a person has a foot length of 20 centimeters, what is their height? So we go back to the graph and we find a foot length of 20 centimeters. I will change to green, I guess. So here's 20 centimeters. We go up somewhere in here. So we're going to be pretty close to 100. So we could say about 100 centimeters or 1 meter. So we would say according to our graph, according to our graph, so we're just reading from the graph, a 20 centimeter long foot will have a height of about 100 centimeters. All right. And the final question for the note, are there any points that stand out on either graph? Yes, the Hulk. All right. He definitely is an outlier for our graph. He is a mutant superhero. So his measurements don't follow and I'm going to use a quotation on normal here. And when I use the word normal, I'm meaning non-superheroes that morph into different sizes, follow a normal person size. Okay? So there's always a reason for that outlier, so you need to go back and take a look and figure what it is. Now, mine's pretty obvious at being the Hulk, but there are different reasons for that. So you got to go back, look at the outlier, and try to figure out why is it an outlier? What's the reason? Was it measured incorrectly? Was there a flaw in the experiment? Did someone not pay attention? You know, there's a whole bunch of reasons for that. So anyway, there is your lesson on scatter plots. If any of this, if there's any confusion, if you're not sure how I was using the graph, please ask the teacher for clarification and they'll give you a hand and further explain the process. But that's all there is to the lesson on scatter plots. Good luck.